Everyone, welcome to my channel. So in this video I'm going to cover the solution to this question called maximum subarray, and also I'm going to do some live coding work. At the same time I'm going to try to follow the general steps we should follow in coding interview. So before we start the real content, I would really appreciate that if you can help subscribe this channel. So let's get started. First of all, let's read through this problem. So given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and the return is sum. So for example 1, we are going to return 6 because the subarray that has the largest sum is 6. We have 4, minus 1, 2, and 1. This is a piece of the subarray that gives us the sum of 6. So on and so forth. So the constraint says that the input array is anywhere, the length is anywhere between 1 to 30k, and each number is between minus 100k to positive 100k. So having said that, let's see how to solve this problem. Solution. So the solution wise, I think we just use the DP solution. So for DP, we could define the DPI as the maximum subarray that contains nums I. So DPI is a subarray that should contain nums I, and also it is the maximum subarray. When I say the maximum, I just mean the maximum of the sum of all the elements within the subarray. So how to compute this one? So DPI essentially it is something. So it's something like max nums I. So either just the single number of the nums I, or it is something like DPI minus 1 plus the nums I. So if the previous one, if DPI minus 1, which is the maximum subarray that contains nums I minus 1, if that one has some positive contribution to our final computation of DPI, then we are just going to include that. Otherwise, we are just going to exclude it. So having said that, the runtime is going to be O of n, which is linear. So that's pretty obvious. So On as the runtime. So if we just use like a 1D array to store the result, we are going to end up with O of n space complexity. But since this one is only depending on the previous one, we can just use like a local variable to store the previous DP. So for example, every time we just store the DPI minus 1, and then if we have computed DPI, then we just change the local variable to store DPI. So something like that. In this case, we can reduce the space complexity to be O of 1. So that's my thought. So having said that, let's do some coding work. So first of all, we are going to have the max subarray. So this one we are going to start with 0. So that is because if everything is, well, it says that given subarray, so find the contiguous. Okay, so it shouldn't be 0 because if everything is like an active number, then we should have the maximum subarray as definitely some because the subarray cannot be empty, so we are just going to initialize the max subarray as nums I, and also we have what is that? So we will have the current max subarray as equal to nums 0. So this current max subarray is pretty much just what we are talking about for the DP array. So the next thing what we are going to do is we are just going to do like a linear scan. So I is equal to 0. It should be equal to 1 currently, and I should be smaller less than nums.length and plus I. So we are looking at the current max subarray is equal to max.max. It's either just the nums I or we are going to have this one as current max subarray plus num sign, which is corresponding to the formula on line 11. So that's the thing, and max subarray is going to be something like max.max. Or the current max subarray, so something like that. And finally, we are just going to return max subarray. So let's just depend on this platform to help us do the debugging work. So it seems like it's okay. Alright, so let's do a submission for it. Okay, so it seems like everything works well at this moment, and we should be in good shape about this question. So if you have any question regarding the solution or anything, so feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.